In today's lesson, we'll be learning how to convert factored form to standard form. In a previous lesson, we learned that a quadratic relation is just a type of pattern, and this pattern can be represented with an equation. This equation can be in factored form or standard form. You can convert factored form to standard form using the process of expanding, and you can convert standard form back to factored form using the process of factoring. Today, we'll be focusing on expanding. In our first example, we have an equation of a quadratic relation in factored form. We want to convert it from factored form to standard form using the process of expanding. The table to the right is going to help us do that. We're going to start by taking 2x and writing it over here. Next, we're going to take -1 and we're going to place it over here. Next, we're going to take 4x and we're going to place it over here. And last, we're going to take +3 and we're going to place it right over here. We're going to get started by multiplying this term with this term and writing the answer in this empty space. Since we're multiplying terms, that means we're going to need to use the product rule. The first step of the product rule is to look at coefficients. The coefficient of this term is +4 and the coefficient of this term is +2. We want to multiply coefficients. So 4 multiplied by 2 is going to give you 8. Next, we want to take a look at bases. This term has a base of x and this term has a base of x. Bases stay the same. So this is going to stay as x. And last, we want to take a look at exponents. This term does not have an exponent and this term does not have an exponent as well, which just means that there is a hidden 1 up there. We want to add exponents, so 1 plus 1 is going to give you 2. We're going to repeat this process by multiplying this term with this term and writing the answer in this empty space. We're going to get started with the coefficients. We already know the coefficient of this term, it's +4. But what about this term? Well, the coefficient there is -1. We want to multiply coefficients. So 4 multiplied by -1 is going to give you -4. Next, we want to take a look at bases. The base of this term is x, but what about that term? Well, there is no base over here, but that doesn't matter because bases stay the same. So this base of x is going to remain the same. And finally, we want to take a look at exponents. We know the exponent of this term is +1. But what about this term? Well, since there is no base, that means there is no exponent. So this one has nothing to add to, and that's going to stay the same. We're going to repeat this process again when multiplying this term with this term and writing the answer in this empty space. First, we want to take a look at coefficients. We know the coefficient for this term is +2. But what about this term? Well, the coefficient there is going to be +3. We want to multiply coefficients. So 3 multiplied by 2 is going to give you 6. Next, we want to take a look at bases. The base for this term is x. But what about this term? Well, there is no base in that term. So it doesn't really matter because bases stay the same. So that base is going to stay the same. I'm going to write an x over here. And last, we want to take a look at exponents. We know the exponent of this term is +1, but what about this term? Well, since there is no base, that means there is no exponent. This one has nothing to add to, which means it's just going to stay the same. We're going to repeat this process one last time when multiplying this term with this term and writing the answer in this box. This should be pretty straightforward since you have +3 multiplied by -1, and that's going to be equal to -3, since a negative times a positive gives you a negative answer. We're going to take these 4 terms and copy them into this bracket. I'm going to rewrite 8x to the power of 2, -4x to the power of 1, 6x to the power of 1. I'm going to add a plus sign in front of it. and -3. At this point, you'll want to look for like terms. Remember, like terms have the same base and the same exponent, which means these two terms are like terms. When combining like terms, you don't want to touch the exponents or the bases. So when I combine them, this is going to become positive 2x to the power of 1. 8x to the power of 2 stays exactly the same, and -3 stays exactly the same. Because we have a number in front of the pair of brackets, we're going to need to use the distributive property, which means everything inside the brackets gets multiplied by -2. So this is going to simplify to -16x squared, and this is going to simplify to -4x to the power of 1, and this is going to simplify to +6. You just have to be careful with your negative and positive signs here. I'm going to clean this up a little bit. We don't like to see exponents of 1, so I'm going to erase that 1. Therefore, we've just converted factored form to standard form.